A technician walks into Iran's Natanz nuclear facility carrying a USB stick. He doesn't know it's infected. Nobody does. The facility is air-gapped, completely isolated from the internet, protected by the most sophisticated security measures Iran can deploy. No external connections, no email, no way for malware to get in, except someone just found a way. The USB stick slides into a computer connected to the facility's industrial control systems. Within seconds, malicious code begins spreading through the network, silently, invisibly, searching for very specific targets. It's not looking for data to steal. It's looking for centrifuges, the precise machines Iran is using to enrich uranium for its nuclear program. And when it finds them, it doesn't announce itself. It doesn't trigger alarms. Instead, it does something far more insidious. It takes control. Deep in the facility, centrifuges begin spinning faster than they were designed to, then slower, then faster again. The fluctuations are subtle at first, barely noticeable, but devastating to the delicate machinery. Technicians monitor their screens, watching the readouts. Everything appears normal. Temperature, normal. Rotation speed, normal. Pressure, within parameters. But it's all lies. The malware has hijacked the monitoring systems, feeding them false data while the actual centrifuges tear themselves apart from the stress. This is Stuxnet, the most sophisticated cyber weapon ever created, allegedly developed by the United States and Israel specifically to sabotage Iran's nuclear program. It's not just a virus. It's the first digital weapon proven to cause physical destruction in the real world, and it changed warfare forever. Stay with us as we dive deeper. The air gap problem. Iran's nuclear facilities were designed with one principle: isolation. The industrial control systems managing the centrifuges weren't connected to the internet. This concept, called air gapping, is considered the gold standard for protecting critical infrastructure. If a system has no network connection to the outside world, how can malware reach it? For years, this seemed insurmountable. Iran's nuclear program operated under this assumption. The centrifuges were controlled by computers that had never touched the internet. From Iran's perspective, this made the facility virtually hack-proof. But Stuxnet's creators found the weakness: humans. Air-gap systems aren't completely isolated. Technicians need to transfer data, update software, and maintain systems. They use USB drives, and if one of those USB drives is infected, the air gap becomes a bridge. The attack required extraordinary patience. Intelligence operatives needed to identify someone with physical access to the facility and infect that person's USB drive without raising suspicion. Once the infected USB was inserted into a computer inside Natanz, Stuxnet activated. The worm exploited multiple zero-day vulnerabilities, security flaws unknown to Microsoft and therefore unpatched. These weren't ordinary security holes. They were carefully hoarded exploits worth millions, being burned for this single operation. The sophistication suggested nation-state resources. Stuxnet spread through the facility's network automatically, but it wasn't indiscriminate. It was searching for a very specific target: Siemens S7300 programmable logic controllers, configured to manage centrifuges of the exact type Iran was using. If it didn't find those specific systems, it remained dormant. The sabotage. When Stuxnet found its target, the real attack began. The malware reached from the digital world into the physical one and started destroying machinery. Uranium enrichment requires centrifuges to spin at incredibly high speeds, thousands of rotations per minute. The process is delicate. Spin them too fast, and mechanical stress tears them apart. Spin them too slow, and enrichment fails. The machines are expensive, difficult to manufacture, and subject to international sanctions, making replacement nearly impossible. Stuxnet manipulated the frequency converters controlling rotation speeds. It would speed them up beyond safe limits, then slow them down. then speed up again. These fluctuations created enormous mechanical stress. Bearings wore out. Rotors became unbalanced. Internal components suffered damage. Over weeks and months, centrifuges began failing at alarming rates. But the most brilliant part wasn't the destruction, it was the deception. The malware intercepted monitoring systems, creating a man-in-the-middle attack between sensors and display screens. When technicians checked their centrifuges, screens showed normal readings. Temperature, pressure, rotation speed, everything appeared correct. The monitoring systems fed them false data recorded when machines actually operated normally, playing it back like a security camera showing yesterday's footage. Iranian technicians saw no cause for alarm, yet centrifuges kept failing. They didn't understand why. They replaced failed units, which Stuxnet promptly destroyed as well. The cycle continued for months before anyone suspected malware. Estimates suggest Stuxnet destroyed roughly 1,000 centrifuges, nearly 20% of Iran's enrichment capacity at Natanz. It delayed Iran's nuclear program by months or years, demonstrating that cyber weapons could achieve strategic objectives previously requiring military strikes. The discovery and aftermath Stuxnet eventually escaped Natanz. By 2010, cybersecurity researchers detected something extraordinary circulating on the internet. The code was unlike anything they'd seen. Large, complex, clearly designed by experts with significant resources. Security researchers reverse-engineered Stuxnet, documenting its capabilities. What they found was shocking. This wasn't random malware for profit. It was a precision weapon designed to sabotage very specific industrial equipment. The sophistication pointed to nation-state actors. The malware used 4 zero-day exploits, had stolen digital certificates, and demonstrated deep knowledge of Siemens industrial control systems. Media reports and leaked documents attributed Stuxnet to a joint US-Israeli operation codenamed Olympic Games. Neither country has officially confirmed involvement, but most experts accept the attribution. Revelation that governments had deployed cyber weapons capable of physical destruction changed global security. If the US and Israel could sabotage Iranian centrifuges, what could China do to American power grids? What could Russia do to European infrastructure? Stuxnet opened Pandora's box. The code was now public, available for analysis by any nation or group. While the specific payload targeted Iranian centrifuges, the techniques could be adapted for other targets. Industrial control systems worldwide became potential targets. Iran learned from Stuxnet, implementing stronger security measures and developing their own cyber capabilities. Other nations studied it closely, reverse engineering techniques, and developing their own cyber weapons. The US and its allies no longer have a monopoly on this capability. Stuxnet changed warfare forever. It proved that malware could physically destroy infrastructure, that air-gapped systems weren't immune to attack, and that cyber weapons could achieve strategic objectives once requiring military force. The worm spread through an isolated network via an infected USB stick, manipulated centrifuges to destroy themselves, and deceived monitoring systems into showing normal operations while machines tore apart. Iran's nuclear program was set back years. The attack remains a triumph of intelligence engineering and a terrifying preview of future conflicts where invisible code causes real-world destruction. Stuxnet is out there now, analyzed and available for anyone to study. The techniques it pioneered have been adapted by nation-states and potentially criminal groups. Every industrial control system, every critical infrastructure, every supposedly isolated network is now a potential target. The digital and physical worlds aren't separate anymore. Stuxnet proved they're dangerously intertwined. What do you think? Was Stuxnet justified as an alternative to military action? Should there be international laws governing cyber weapons? Share your thoughts in the comments below, and remember to like, subscribe, and click on the next video on your screen.